Hello, welcome back. We're doing our last lesson in solving compound inequalities. It'll be exactly the same process. We'll just have slightly more complicated problems with some interesting twists and turns along the way to show you how to handle the different things that you might run into. Okay, our first example is going to be 7x minus 1 greater than 11, x plus 11 is what I'm trying to write over here. X plus 11. And that's going to be ORed with negative 11 x is greater than negative 33. So here's two inequalities, and we're saying this one has to be true or this one. What does it look like from a solution set point of view? So the first thing we do with this one is we start by moving the negative 1 over here by adding 1 to both sides. Well, you could do it a number of ways. We can start by moving the x over here because we have x on both sides. Let's do that first. Subtract x from both sides. We'll have 6x minus 1 greater than 11. All we did was subtract x here, give me 0, subtract x here, give me 6x. Now I'm going to move the 1 over, so it'll be 6x greater than 12. What I did here is add 1 here, giving me 0, add 1 here, give me 12. And then finally, x is going to be greater than, what do you think? Divide 6 both sides, you're going to get a 2 on the right-hand side. You don't have to flip signs or anything because you're dividing by a positive number. So this is 1/2 of the answer, but this is going to be ORed with whatever we get over here. So what do we have here? It's already almost done. All we have to do is divide by the 11. So what we'll have is x. When we divide by the negative 11, I should say, we'll have to flip the sign of this inequality. And then we'll have negative 33. Of course, will be divided by the negative 11. So I'll just drag the answer down a little farther. It'll be x less than positive, because negative divided by negative is positive, 3. So we have x greater than 2 or x less than 3. Is it possible for x to be bigger than 2 but ORed with x less than 3. Let's see on the number line how it works out. We're saying x greater than 2. So we put an open circle here, and we're saying greater than 2 would be all numbers to the right. We expect it to be a branching in both directions, right? X less than 3. So 3 would be right here, and it would be less than that, so it would be all the numbers to the left. But you see what's happened is because they're ORed, it's either one has to be true, and because basically they overlap like this, then all of the numbers on the number line are actually valid solutions. So we can actually take away our little open circles that we had and just close everything up. And the answer to this is actually all real numbers is the solution. Why is it all real numbers? Because we're saying that x has to be bigger than 2 to be a solution, or x could be less than 3. But any number can be simultaneously bigger than 2 and less than 3, right? If you OR them, now I shouldn't say and, either one. It needs to satisfy this number, this inequality, or this one. So you pick any number you want, pick 100. Okay, 100 is greater than 2, 100, so it satisfies this guy. 100 is not less than 3, but that's okay because you only have to satisfy one or the other, right? You can pick negative 5. Negative 5 does not work to be bigger than 2, but negative 5 does work to be less than 3, so it satisfies this one, as long as it's one or the other. So the way you do is you attempt to plot it, and we said greater than 2 was all numbers this way, less than 3 was all numbers this way, and only either one or the other can be true, so any number actually will satisfy one or the other to be true. So we say all real numbers. So you don't have to circle this anymore. When you put them together, all numbers satisfy this guy, and that's what you would put on your answer. Okay, so it's important when you get down to the final step here to look at what you got and see if you can make sense of it. All right, now the next one we're going to do will be as follows. It'll be x minus 7 less than 3x minus 5 less than x plus 11. So notice that we have a double inequality, a compound inequality, written as an and because we have the term with x in the middle, and we have greater than this term, less than this term. So when we know it's written like this, we suspect strongly it's going to be an and that's what it actually is going to be. So let's break it up into its two parts. So we read from the inside out, it'll be 3x minus 5, reading it from this direction, greater than x minus 7, and, because this format means that it's and, inside out, 3x minus 5 less than x plus 11. So now we have to satisfy both of them, not one or the other, but both of them at the same time. So we think it'll form a line segment kind of deal. Let's see what we have. Let's move the x